What's up, everyone? We are back with 13.2, which is all about angles. Angles in degrees, angles in radians, angles on something called the unit circle on our graph. Typically, we've seen angles as part of polygons on the inside of shapes. Well, from here on out, you're actually probably going to see angles in the form of the center of a circle the rest of the way, for most of it. That's the kind of math we're getting to, where we have angles in circles. So I'm going to be going through these notes. It's not nearly as much material as 13.1. However, it is a lot more new material. So really have your notes next to you, be taking good notes on those examples, definitions, jot down anything you need to. And I'm going to stop screen sharing at various points because I want to try to illustrate something, and I want my picture to be a little bit bigger so you can see it kind of with my own body kinesthetic movements. So looking at this though, screen sharing right now, angles and the way we're going to look at them for pretty much the rest of the chapter, I can't say that, a lot of the rest of the chapter will be on the coordinate plane. You can see the origin right here. So x-axis, y-axis, and here's the origin, drawing a giant dot there. Angles are going to be measured from the positive x-axis. That is their starting point, all right? And typically, traditionally, they will be going up. They will be going counterclockwise. So a couple things in this diagram here. One thing I want you to notice is we know 90 degrees means perpendicular. This is a 90-degree angle right here. I can put a little box there. Well, if you look, going from my initial side, my positive x-axis, right here to my y-axis, that is a 90-degree angle. That is what we would call that. If we go all the way to the negative x-axis, that would get us 180 degrees. It's two 90s. It's also a 180. And if you say you ski or snowboard or figure skate or skateboard, you might know, okay, a 180 is like halfway around. We are halfway around our circle. If we go another 90 degrees, we get to 270. And then finally, a full circle, as I bet a lot of you know, is a 360. 360 degrees is one full circle, one full revolution. So a couple things, pieces of vocab. The vertex is kind of that anchor point for the angle, and typically we will have that at the origin. The initial side is the starting side of our angle, and in something called standard position, which is what we're going to look at 99% of the time, that initial side is on the positive x-axis. The terminal side is the ending side of our angle. Wherever it ends up, terminal means ending. So this right here is an angle in standard position. If I had to estimate, I might say that's 130 degrees maybe. You know, it's in between 90 and 180, I know. It's in between there, and it looks mostly in between, maybe a tiny bit closer to 90 to my eyes. So we could say that this is roughly maybe 130 degrees, just as a guess, between 90 and 180. So pretty much everything that is written here, we just talked about. When the initial side is along the positive x-axis and the vertex is on the origin, the angle is in standard position, and that's just typically what we always see, basically. Now, I did mention that we go up from the positive x-axis. Counterclockwise. Counterclockwise means we have a positive angle measure. This angle that they've drawn there, they've labeled as 225 degrees. Looks about right because 90, 180, not quite to 270, but definitely past 180, kind of right in the middle. So 225 degrees, that's believable. Negative angle measures can be obtained. Your geometry told you that there's no such thing as a negative angle measure. They sort of lied to you, just because you weren't ready for that truth. But a negative angle measure can be obtained by going clockwise down from the positive x-axis. So again, we're going 90 degrees, but it's in the negative direction. So negative 90, negative 180, and then they've labeled this as negative 210 degrees. Again, I buy it. It's a little bit past 180. So negative 210 degrees looks about right. Negative angle measures go down from the positive x-axis. Positive angle measures go up. All right. When terminal sides rotate, when we have our ending side on our circle, we're not limited to just 0 to 360 degrees. We could make multiple circles if we wanted. So right here, again, the notes say make one or more revolutions. Any angle whose terminal side has made exactly one revolution has a measure of 360 degrees. Now, if you look here, they've labeled this overall angle as 495 degrees because they went around, that's 360, plus another 90 gets us to 450, and another 45 gets us to 495. We can have angle measures that are more than 360. We could keep going circles forever and ever and ever, really. So here's what we're going to be doing in just a second. We're going to be drawing angles on this coordinate plane, and I'm going to color code mine. Drawing angles in standard positions, starting at that positive x-axis for each of these degree measures, 100 degrees, 200 degrees, 360, 540, 720. But before we do that, I want to stop sharing my screen and talk to you a little bit, just again, kinesthetically, if you will. And I'm kind of terrified that this video recording is going to flip and everything will be backwards, but if it is, I'll just redo this video, I guess. So whatever you're watching right now is the non-flipped, the accurate version. This pencil is going to represent our positive x-axis going this way. So any angle will start from here and will, here's our vertex, the eraser, and we'll go up for a positive angle measurement. Now, if I asked you to estimate where is 40 degrees, how would you do that? Well, we would say this is 0, but this is 90. The highlighter stylus is the terminal side. This is 90, this is 0. So 40, I would say, is maybe like right around here. What about 97 degrees? Well, I would draw and I would say, okay, well, that's 90, so just a tiny bit past that. 97 degrees would be here. 200 degrees, we could say, well, 0, 90, 180, and then I need to go 20 more degrees, so like 200 maybe is right around here, I guess. Because here's 180, so a little bit more, 200. We can guesstimate and draw pretty decent sketches of all these angles. Now, what if I asked you for 30 degrees? You would probably say, well, that's right about here, a little bit up from 0. What if I asked you for 390 degrees? We know that a full revolution is 360, but we wanted 390, so we need to go 30 more. 390 would end up in the kind of the exact same spot as 30. Because we just did one full circle and then another 30. So we can have angles that line up in the exact same spot. That's going to be an important concept coming up too, here in just a second. But before we get to that, let me share my screen again. And let's draw these angles that we saw earlier. Where is 100? I'm hoping that this, after talking about that with my pencil and my highlighter, this goes really well. Where is 100 degrees? Well, 100 degrees would be past 90, but not too much past 90. So I'm going to call it right there. That's 100 degrees. It's a pretty decent sketch. Where is 200 degrees? Well, 90, 180, and then 200. A little bit more. So blue, again, color coding this, that would be 200 degrees just about. Third one's pretty easy. Where's 360 degrees? I can get that exact. 360 would be one full revolution, one full circle. 540, so 540, got to think a little bit. 540, I know that's going to be more than one full circle. So if I subtract that out, it's 180. So 540 will equal one full circle plus 180. So maybe I'll go on the inside of my drawing right now because this is getting a little crowded. One full circle plus 180. That'll get me to 540 degrees in green here. One full circle plus 180. Last one, 720 degrees. Well, I know that that is 360 plus 360. So two full circles. So 1, 2, ending right there. So I know it looks kind of trippy right now, but I'm hoping when I wasn't screen sharing and then this is helping you visualize what these angles are in terms of a circle on a circle. So how is this going to help us? Well, it's going to help us quite a lot. Before we kind of start looking at triangles within these angles and such, though, there are a couple more things we have to talk about. One of them is coterminal angles. Coterminal, co means with, terminal, we saw what terminal sides are. So coterminal angles are angles that end up in the exact same place. Let me give you an example. 0 degrees and 360 degrees are coterminal angles because 0 is right here, 360 is one full circle, we end up in exactly the same place. Negative 360 would actually also be coterminal with those. Negative 360 means go down all the way, one full circle, we end up in the same place, our starting place. So one of the things that will be useful, helpful, and necessary in this chapter is to find coterminal angles. I gave the example earlier, kind of on purpose, with 30 degrees, because here we're asked to find one angle with a positive measure and one angle with a negative measure that are coterminal with the angle measurement given. So we're given 30 degrees. How would I find a coterminal angle with a positive measure? Well, if I add a full circle, I will always end up exactly where I was. So 30 plus 360, 390 degrees is coterminal with 30. 30 is just a little bit up. 390 would be a full circle and a little bit up. And so those are coterminal angles. How would I find a negative measure coterminal angle? Well, take your starting place and maybe subtract 360. Negative 330 degrees would be a negative coterminal angle with 30 degrees. So negative means go down. We don't go down a full circle, almost a full circle though, almost 360, we end up in the same spot. So I'm going to draw these really quickly, sketch them on the circle on the right, and then we'll talk about all these pies that suddenly invaded the picture. 30 degrees, our starting is, oh gosh, is right here. So positive coterminal would be 30 plus 360, so 30 and then another full circle gets us there. And then 30 minus 360 is 30, start at 30 and then go down a full circle, 30 minus 360, we end up at that same coterminal spot of 30 degrees. So coterminal just means angles that end up on the same spot on the circle. Now, what is going on with pies? What is even happening right now? These pies represent another way to express and measure angles. This is something called radians. We actually saw this in the last video when I had you make sure that your calculator was set in degree mode and not radian mode. That's what this is all about. So radians are just another way to express measurements of a circle. And what I want you to know is that as we go through algebra and geometry and algebra 3, 4, I mean, we typically use degrees more, but as you'll see in chapter 13, we're going to transition to using radians more. And then pre-calc, you're using mostly radians, and calc, you're using all radians. And so the higher levels of math use radians because they're actually kind of more convenient, and they make a little bit more sense for circles. And so that's what we'll be looking towards. Now, a couple things I want to draw your attention to on this picture. I'm looking at the outsides here. Here's 0. 1 full circle in radians, if we go from 0, same direction, everything, 1 full circle is 2 pi. Okay, so 360 degrees is equal to 2 pi radians. Those two angle measurements are the same. And you can kind of see that right here represented on this diagram. 360, 2 pi are the same. Well, if 2 pi is a full circle, then what is half of a circle? 180 degrees would be 1 pi, right? Because it's half a circle, so 1 pi radians. Sure enough, there it is, 180 pi. You might look at then, okay, so then if 180 is pi, what would 90 be? Well, 90 is half of 180. It's pi over 2 radians. So we've seen 0 is 0, 90 is pi over 2, pi is 180. 3 pi over 2 is 270 degrees. 360 is 2 pi. Now, the big thing that you need to know right now, because I know I'm throwing a lot at you, the big thing you need to know is that 360 degrees is the same as 2 pi. Why do you need to know that for coterminal angles? Because, well, how do we always get coterminal angles? We said we add or subtract a full circle. If we start at 7 pi over 6, I'm going to find that on my circle. 7 pi over 6, here we are. So it's 210 degrees, but we're talking in radians for this problem. If I want to find a full circle or a coterminal angle with a positive measure, I'm going to just add 2 pi. I'm going to add a full circle the same way we added and subtracted 360 above. I'm going to add 2 pi. Now, adding 2 pi over 1, we know that we need a common denominator. So maybe multiply them both by 6 to get that common denominator. So 7 pi over 6 plus 12 pi over 6, which would equal 19 pi's over 6. And that would be our positive coterminal angle in radians. Again, this was just to get a common denominator so we could add our fractions. We've been doing that forever. 7 pi over 6 plus 12 pi over 6, 19 pi over 6. We added 1 full circle. What about subtracting a full circle? So 7 pi over 6 minus 2 pi. Again, I'll get a common denominator. So 7 pi over 6 minus 12 pi over 6. Negative 5 pi over 6 is a coterminal angle in radians with 7 pi over 6, our starting one. So for coterminal angles where we're starting the radian discussion, you simply need to add and subtract full circles, 2 pi. I would like you to pause the video and try these next two. They're kind of the exact same problems as above, just different numbers. I want a positive and a negative coterminal angle with 380 degrees and with 11 pi over 20. Add and subtract full circles, then unpause your video and see if we got the same thing. All right, here's what I got for those two problems. Check my answers, check yours. 380, I added a full circle. I added 360 degrees, got 740. Something interesting happened on part 2 of this problem. I subtracted a full circle. 380 minus 360, I got 20 degrees, which is a valid coterminal angle. However, we were asked for a positive and a negative coterminal angle. 20 is also positive, kind of like that 740. If this happens, what should you do? Just subtract another full circle. We can keep subtracting or adding full circles till the end of time. So I said 20 minus 360, that gave me negative 340 degrees for my negative coterminal angle. Radians, less familiar to us, but I said 11 pi over 20. Okay, I know I need to add a full circle, which is 2 pi. So 11 pi over 20 plus 2 pi, I got a common denominator, 40 pi over 20. And that came out to be 51 pi over 20 for my positive coterminal angle and negative 29 pi over 20 for my negative coterminal angle. Take a second, check your answers against mine, check your work against mine, make sure it clicks, and if it doesn't, jot it down so that you can ask about it when I see you next. So I've already kind of shown you this and led this discussion, but right here, if degrees and radians are kind of sort of the same, let's fill in this chart. We know that 0 degrees is 0 radians. We know that 360 degrees is 2 pi radians. If we know that, we can pretty much get the rest of this. 180 degrees is a half circle. So what's halfway in between 0 and 2 pi? 180 degrees is pi radians. So I'll start filling it in. So this is 0 radians, this is pi, this is also 2 pi. What would 90 degrees be? What's halfway in between 0 and 180? Well, that would be 90 or pi over 2 in terms of radians, half a pi, pi over 2. And what's in between 1 pi and 2 pi? Well, that would be 1.5 pi or 3 pi over 2, which is pretty much always how you'll see it expressed. Now I have a note down there boxed in red that says always leave radians in terms of pi. I don't want to hear about 3.14 radians. I mean, leave it in terms of pi because that is exact. That is not rounded. And we want to be as precise as possible with this. So knowing these touch points for degree and radian equivalencies is a really good place to start. 0, 0, 360 is 2 pi. And then you can fill in from there. Half of that, you know, and in between the halves, so the quarter around the circle, pi over 2, things like that. All right, then last thing to talk about. Yes, you will eventually have all of the equivalencies in this screen memorized. You will know that 2 pi over 3 is the same as 120 degrees, and that 7 pi over 4 is 315 degrees. You'll have all these memorized. But for now, there's got to be a way to convert, right? Between degrees and radians. Absolutely right. Couple boxed equations down there that you can jot down. On the left, it says if we know radians, then we can find degrees by taking our radians times 180 over pi. We're just converting units. So radians times 180 over pi. If we know our degrees, we can multiply by pi over 180 to get to our radians. So just a simple, quick calculation to translate degrees to radians or radians to degrees. So practicing this, what is negative 110 degrees in terms of radians? Here's what I would do. Here's how I think about it. I would say negative 110 degrees, and I know I need to multiply by either pi over 180 or 180 over pi. And how do we know which one? Well, I want to cancel out my degrees. I'm currently in degrees. I want to put my degrees on bottom then so I can cancel out my degrees. I'm going to multiply by pi over 180. Now the degrees cancel, and we get negative 110 pi over 180. We can divide both those by 10, get rid of those zeros, negative 11 pi over 18. Negative 110 degrees is the same as negative 11 pi over 18 radians. Try that second one. Multiply by your multiplying conversion factor, cancel out the degrees, see what you get in terms of pi. I'm going to quietly do it while you're working. and I got for my final answer 2 pi over 9 radians. 40 over 180 divided by 10, 4 over 18 divided by 2, 2 pi over 9 radians. Okay. So this is how to convert from degrees to radians. What about the other way? Convert to degrees. Well, if we start with pi over 10, I know I need to multiply by either pi over 180 or 180 over pi. What do I want to cancel out this time? I want to cancel out my radians. I want to cancel out those pi's. So I'm going to put pi on bottom, 180 on top. That gives me 180 over 10, 180 degrees over 10, or divide by 10 on both of them, 18 degrees. Pi over 10 radians is 18 degrees. Same as before, I want you to try this last problem for today. Negative 8 pi over 5, multiply by your conversion factor. See what you get? I'm gonna do it silently along with you. And I got negative 288 degrees. Numbers got a little big. If you were watching my screen, I was definitely pulling out my calculator to help. 8 times 180 is 1440. Divided by 5, 288 degrees. It was negative, so negative 288 degrees. So again, maybe didn't cover as much ground as in 13.1, but covered more new ground, I would say. Started up here talking about angles on a circle and how we standard position, we start at that positive x-axis. Positive angles go up, negative angles go down. Talked about drawing all sorts of angles, maybe more than 360 on a circle. Coterminal angles, angles that end up in the same spots in both degrees and radians. How do we find them? We just add full circles. And then how to convert between degrees and radians. So again, chapter 13 is really important. In first semester, I would pick chapter 5, factoring and solving quadratics, as the most essential chapter all of first semester. Now, does that mean the other ones are unimportant? No. But that one's probably the one that has the most writing on it. Same with chapter 13 for this semester. Trigonometry, huge. Huge moving forward. Huge in physics. Huge in like I said, everyday life. 13.1, I kind of talked about how you use a lot of trig in construction, in stagecraft, in personal home projects that you need to calculate precise measurements. And so chapter 13 sets us up so well for the future if we can master it. Angles, we're starting to get a little more abstract. Angles inside a circle, which is a little bit weird. So if you're feeling a little uncomfortable right now, I get it. But really take a look at these practice problems, really work hard at them, make sure you feel good about your understanding of these concepts. And of course, if you have questions, let me know so that I can help clear those up and help you feel really good. But that is it for 13.2. 13.3 will be coming next. I will see you guys in that video.